In this video, we're going to explore some further capabilities of working with data frames by exploring an actual data set. Now, the data set we're going to look at is New York City restaurant health inspection records. And to follow along with the examples here, I would encourage you to download the data set from this URL over here. And this is a very small subset of the entire data set. Now, if you're interested in exploring the full data set, you could take a look at the New York City Open Data Initiative, and there are lots and lots of really interesting data sets about various aspects of local government. So if you're interested, this is certainly a very good site to take a look at. So first thing we're going to do is load the data set, and this is something we've seen before. So to do that, we use read CSV. So we first import Pandas as PD, and PD is just an alias for Pandas. And then we're going to read the file restaurantinspections.csv. And in this case, we're letting read CSV, we're telling read CSV that the encoding, the character encoding, so how the data in that file is represented, is using Latin encoding. If you don't specify that, this just happens to give an error. But generally speaking, you don't need to supply this additional argument here. It's just in this case we need to avoid an error. So if we execute this, it takes a second and it reads the file. And the next thing we might want to look at is what are the various columns in the CSV file. So to do that, we're going to refer to the columns attribute of the data frame. So it's just .columns. And if I execute this, it gives me a list of the columns. So DBA is the name of the restaurant, followed by the borough where the restaurant is, the cuisine description, inspection date. So each of these records is a record of an inspection, of a health inspection, and then there's a violation description and the score. It's a numeric score. The higher the score, the worse the violation is, and then the grade that's assigned to the restaurant, and then when the date was issued. So these are the columns of the data set. So let's take a look at the actual data set. Let's look at the first few entries, and we're going to use the method head to do that. So if I execute that, I get first few records. So as you can see, here are the few restaurants. These are from a few years back. If you look at the New York City site, obviously you'd get updated data. I just want to note that in this case, the explicit row index is just a numeric value starting at 0. So in this case, it just happens to match the implicit index of the rows, and then the columns are what we just described earlier, starting with the restaurant name, the borough, and all the way to the grade and the date of the grade. Now you'll notice that in some cases there are no valid values. So if we look over here, NAN, that means the value is missing. So we're going to look at that a little later. So whenever there's no data available, it's going to be represented as NaN, which is short for not a number. Okay, so moving on, this is just quick review. Let's suppose we're interested to see the full text of the violation for this restaurant, 810 Deli and Cafe in Manhattan. And this is 3 years old or so. So let's see what that looks like. So here we're going to use the loc operator, and we're going to specify the row index 4. This is the explicit row index, and then the column violation description. So that gives us this over here. So let's look at the full details of what a violation would look like to execute this. Well, there we go. So violation, there's some sewage associated flies present in the facility, etc. Not very appetizing. Might want to make you think twice about going to the restaurant. But surprisingly, the score is still relatively low. Score of 20 is, as we're going to see, is not particularly alarming. As I said, the higher the scores, the worse off restaurant is. Okay, so moving on. Now, it's often a good idea to look at the column data types. So when you have a data file and you call read CSV to read the data into a data frame, oftentimes read CSV does a pretty good job at detecting what data is stored in the various columns in the CSV file. But sometimes, this process doesn't go so well, so it's important to see if it read things correctly. Now, to do that, we could, given the data frame, in this case our data frame is inspections, we could refer to the dtypes attribute. So if we execute the statement, we get the data types of the columns. Now, in this case, we just have 3 different types. So the index, the first column, is an additional, essentially a record number. So this is represented as an integer. The score is a float, and everything else is an object. In this case, really, the object is a string. So this seems okay. Nothing to worry about here. Okay, so now one question we might be interested in answering is, well, how many restaurants are in each borough in this data set? And again, this is a partial data set of 500 records. So how do we determine how many restaurants are in each borough? Pandas data frame gives us a method called value counts, which accumulates the counts of records for each category in a given column. And then in our case, the category is going to be the borough. So if you think of the borough column, one category is going to be Manhattan, another is going to be Brooklyn, Queens, etc. So these are our categories for the borough column, and we're going to use value counts to see how many restaurants are in each category. So this is a very useful function to know about. So here's call to the function, and I'm just calling it on the borough column. So again, the square bracket notation is to refer to a column in this case, and I do value counts on column. So let's execute this, and this shows that for this particular data set, 192 of the 500 records are Manhattan, and then 128 in Brooklyn, and so on and so forth. Okay, so moving on. Now let's suppose we're just interested to look at the restaurant inspection records just for Staten Island. So how would we go about that? So if you remember from last time, it's possible to filter rows in the data frame based on some Boolean criteria. And in the previous videos, we used the log operator to achieve this, but we could also do it just using this square bracket notation. So in this case, I would like to extract the rows for which this criteria holds true. So if we read the criteria, so I'm interested in the records for which the value of the column borrow, the borrow column evaluates the Staten Island. So in essence, that gives me the restaurants in Staten Island. So let me execute this. And here we are. There weren't lots of restaurants in Staten Island. I think it was 11 or 13 or so. And here we're just, the screen doesn't fit all of them, but we can see that it picked out, on the bar column, we're only showing the restaurants in Staten Island. Okay, so moving on. The last time we looked at how to plot a histogram of a column. So here we're going to look at some further details of getting histogram. And if you recall, the histogram just gives us a sense of the distribution of some variable. And it gives by giving us the frequency of occurrence over a range of values. So here we're interested in looking at the histogram of scores. Now, same as before, we would like the graphic to appear in our notebook. So we're going to say this is an inline graphic, matplotlib inline, and then we're going to generate the histogram of the scores. And the difference here is that we're going to actually label the x-axis and the y-axis. Now, in order to do that, we need to have some handle, some way to reference the axes. So when you call the histogram method, what it gives you back actually is the axis object, and we're representing that as ax. And then using ax, we could set the labels, the x and y labels on it. Okay, so let's run this and take a look at what these scores look like. Let's see, so here we are. Now, this is, so we get a sense of the distribution of scores. So as you can see, the specific example of a restaurant we looked at was right here, where it's around 20. But it seems like the bulk of the restaurants, so about a little over 200, so this is a number of restaurants, the frequency of a given score. So there's about roughly half of the restaurants score in this range between, let's say, 10 and 20 or so. Okay, and then you also find a small minority where the score is much larger than that. So these are perhaps the restaurants that get a score of C or might be closed down by the health department. I'm sure there are lots of rules governing that. But again, this gives us a sense, for this data set, what can we expect in terms of health inspection scores. Okay, now another very useful thing to be able to do is for a given column, and then here we're referring to a numeric column, we'd usually be interested in finding out some basic statistics like the mean value, the average value in a column, the minimum, the maximum value, and even we might even be interested in knowing what are the n largest or n smallest values in this column. N is a parameter that we specify. So if we could ask for the 5 largest values in a column. So let's see how we could do that. So given a column, given the score column, I could get the mean of that column by calling the mean method. And so here we can see that the average score for this data set is 17.8. The minimum value is 0. So there are some restaurants who have a perfect score of 0. Maximum value is 78. And then if I'm interested in seeing, let's say, the 5 largest scores, so I'm going to call the method n largest and send to it the argument n with a value 5. So execute this. So what I get back are the indices of the restaurants with the largest scores and along with the corresponding score. So the restaurant at index 331 had a score of 78, the one at 220 had a score of 76, etc. Okay, and if we're interested, we could dig deeper and look at those restaurants, look at the description of the health inspection and so forth. Okay, now as we've seen in the data set, it's often the case that there are some missing values in the data sets. So this could be, sometimes this is due to the fact that, just the value was not recorded. The value was available, but no one bothered to record it. That's a possibility. And then, or sometimes it could be that a value for a given column of a record does not make sense. So in both cases, the missing value is represented as none or NaN in the data frame. So whenever we see either of these values, we could, we know that value is missing. Now we're not gonna, in this video, we're not gonna get into details of how to deal with missing values, but this is something we could, there are some techniques for dealing with at least option 1 over here. Okay, so now the way we could investigate which values are missing is using this function isNA. Now isNA is a function that gives us back. So given the data frame, it gives us back a data frame of the same dimension, but it's a Boolean data frame. So it contains true for an entry if the entry is missing, and it contains false if there is a value in that entry. Okay, so let's give this a try. So again, you know, this is our inspections data frame. I'm going to call is NA, and it gives us back this data frame, which we're going to call DF. And I'm just going to look at the first 3 rows of that Boolean data frame that tells us if there are missing values or not. So if I were to execute this, you can see the columns are identical to the original data frame. And then the values are true or false. So false means there is a value in here, it's not missing. And then there are a few entries, well, here's a couple of them where there's missing data. Now, sometimes this could be too much information, so we might just be interested in perhaps looking at how many, for a given column, how many of the values are missing, as opposed to which ones are missing exactly. So to do that, we could just simply, let's see, sum the columns. So given the data frame, I'm gonna call the sum function, and it's gonna sum up the true values in each of the columns. So I'll execute this. Here we are. It tells me that in my first column, the DBA column, no records are missing. All the restaurant names are there. And there are 14 instances where the violation had no description. And you know, there are 30 records for which there is no score. Now there's a much larger number of records that don't have grades or grade date, but that could be because you know, grade is something that's assigned you know, at the end of the process, so it's not necessarily that every inspection will lead to a grade. So this could explain why there are so many records of restaurants without a grade. Okay, now just to, you know, brief note, this is more of you know, Python detail as opposed to data analysis detail. So in order for us to sum up the number of missing values, we've done that in 2 steps. So this is what we did in the previous slide. So we called isNA on our data frame, and we got a data frame back, and then using that data frame, we summed up the results. We summed up the true values in the columns. Now, as it turns out, we could combine both of these steps into one by chaining the method calls. So this is the process we're using. We're chaining the method calls. So in essence, the way to read this is that this is executed first. So inspections.isNA is executed first. We get back a data frame, and then using that data frame, I call sum on it. So this is evaluated from left to right, and it saves us from having to break up something into multiple steps. Now this is, I point this out because this is fairly common practice, so it's good to be familiar with the syntax. And you know, there's technically not a limit to how many method calls you could chain, as long as the chaining makes sense, but sometimes it gets a bit harder to read code when you chain, let's say, 5 method calls. It's much harder to interpret what the intention is. So in general, I would say maybe chaining 2 method calls is perfectly fine. 5 is probably not reasonable. Okay. The last idea we're going to look at in this video is this notion of grouping. So instead of looking at analyzing the statistics for an entire column, oftentimes we want to be able to do some analysis based on groupings within the column. And then the way we're going to do that is identify the groupings by splitting data based on some criteria. Okay, so as an example, so let's suppose we're interested in the average score per borrow. So in this case, the borrow is our grouping, and we're interested in the mean score for each of the groupings. So let's see how we could do that. Well, so there's this method named group by, and the way to interpret the statement is that we're interested in the score column, so inspection subscore, but we want to group by the borrow, inspections of borrow. So this is going to give us the score, the score of aggregated by the borrow. Now, this operation is simply doing the data pre-processing. It's not actually producing the mean yet. It's just doing the grouping behind the scenes. So we're going to execute this, and there's no output here. We haven't output anything. And then in order to obtain the mean scores, we're going to call the aggregation function mean, which computes the average of each group. Okay, so if we execute that, here we are. So these are the average scores for each of the boroughs. So this is the average score for Bronx, Brooklyn, Manhattan, Queens, Staten Island. Okay, now another example of grouping would be, let's say I'm interested for each borough, I'm interested in how many in the count of restaurants that got an A, and the count of restaurants that got a B, count of restaurants that got a C. So the grouping is still the borough, but I'm not interested in the numerical score. I'm interested in the counts of grades within each borough. Okay, so this is a little more involved to think about logically, but it turns out it's fairly easy to do. So here's how we could achieve this. So again, we're looking at the borrows, and we want to group by grade, not the score. We're going to group by the grade. But here, because the grade is not a numerical value, it's A, B, or C, etc., we're not going to compute the mean. It doesn't make sense to compute the mean of a categorical value. So we're just going to count how many A's we have, how many B's we have, how many C's we have for each borough. So that's where you use value counts. So if we were to execute this, we get the results here. So we see that in Manhattan, we got 71 restaurants got a grade of A. In Brooklyn, 50 restaurants got an A, etc. And then we get the B's and the C's. Okay, so So with that, I hope you've developed some ideas about how to explore a data set, and a lot of these ideas are applicable to any data set, and they're the kind of things you want to do first to get an understanding of your data. So